Hi everyone, it's Mr. Morrissey, and here we go with this next problem. Let us graph the rectangle. I'd recommend having graph paper, but there's the rectangle. We already know 2 points on the hyperbola. Since this is a horizontal hyperbola, you're going to have a point here, you're going to have a point here. That's at 6 and -6. And let's draw in the asymptotes. So there is my hyperbola. And vertices, there are the vertices, 6, 0, -6, 0. And let's see, there aren't covertices, okay? You might be wondering that. So not like the ellipse. The asymptotes, let's see, we want to solve for y. So that's going to be this. So we're going to get, again, when you plug in like a million or a huge number, the subtracting by 9 is really inconsequential. So really, you're just going to get plus or minus. That's going to be the square root of a fourth. So when you square root this, okay, I'm really writing this weird. So this is y equals plus or minus a half x. So y equals plus or minus a half x is going to be the equation of the asymptotes. So when it says identify asymptotes, it really should say find the equation of the asymptotes. So it's y equals 1/2 x or negative 1/2 x. And then for the foci we're just going to use c squared equals a squared plus b squared real quick. And let us see here. This is easy. We already know 36 and 9 is 45. So plus or minus square root of 45, which is 9 times 5. So that's plus or minus 3 root 5. So we're going to have just a point out here and a point out here. And these asymptotes, okay, are going to be 6 plus 3 root 5, 0, or the opposite. So let's see. -6 minus 3 root 5, 0. Okay? So there are foci. So this is foci. This here is foci. And we're done. Okay. We're going to end with two problems that are like completing the square. Okay, so they're going to be sort of hard. So remember, with completing the square, I would recommend grouping the terms together. Here we're trying to find the length of the conjugate axis. So let's see. I'm going to put the constant term over to the right-hand side. Now I take 10 and divide that by 2. That's 5. 5 squared is 25. Now here I need to factor out a 4. Okay. So -6 divided by 2 squared. That looks like it's 9. So I'm adding 9 here. But then I need to figure out what I'm actually effectively adding to both sides. So I'm adding 25 from right here. Okay, conveniently that cancels that out. But then 9 times -4, that's -36. So I need to subtract 36 to both sides. So let's see what we get. Okay, earlier in the lesson I said that the last number had to be a 1. So you might stop here and you're like, oh God, I've never seen something like this before. What am I supposed to do? Well, here you can divide by negative 36 and you'll get a 1 on the right hand side. So I want you to do that real quick. Okay, so we are going to get I move these terms around and I'm going to get, whoops, okay, let's see if that makes sense. Y minus 3 squared divided by 9 minus, so the minus in the middle indicates you're dealing with a hyperbola and not an ellipse, x plus 5 squared over 36 equals 1. Okay, so it says conjugate axis. You need to know what that means. So the transverse axis, it says on your notes, if you look, let me show you where this is. So if you go back to page 2, so the transverse axis is right here. That's the axis that has the vertex on it. So the conjugate axis is the sort of the axis that has the B points on it. So we come back and we look. This is a tricky little problem. So in this case, the transverse axis is going to be the one with the B term. So here, the B term is actually bigger than the A term. So this problem really tests your understanding of hyperbolas and knowing here that the transverse axis is actually equal to 2b. Well, b squared is 36, b is plus or minus 6, but really like the absolute value of the distance is 6. So 2b is 12. The answer for this problem is 12. Okay? We have one more problem to do, and it's actually a hard problem. So get ready. Crack your knuckles. I'm just having a sip of tea here. All right. Let's see. We got one more to do. Here we go. Find the equation of the asymptotes of this equation. Okay, I'll tell you right now, I had to use a calculator for some of this work, just for some of the bigger number math, but let's do our best. I'm going to group together the y terms. Whoops. I don't know why I'm starting with, well, let's just see what happens. I'm going to put the 291 over to the other side, and let's see. That's 12. Plus 12? Yeah, plus 12x. Okay. So I would check your work at this point to make sure when you redistribute, you go back to where you started. So 49 times 2 is 98. That works. The minus 4 on the outside should be plus 12. Yeah, looks good. Okay. So let's keep going. So let's complete the square. You notice that that's been something we've done several times. So I would say you're going to definitely be expected to know how to do that. Sorry, guys. I had this like sneaking suspicion the microphone was off. So here we go. So let's see. So 12 divided by 2 is 6. Squared is 36. All right. So it looks like we're adding 49 and then minusing 36 times 4, I think is 144. Let me check that. So here's what I get when I do the work here. So on the right-hand side, I get 196. And then, since I need to have this equal 1, I'm going to get, looks like that's what I'm going to get. And when I simplify that, so I did use a calculator, um, but I'm going to get something like, so y plus 1 over 4 minus, what does that simplify to? So I got 4 over 49. That doesn't make sense. So I need to, let me pull out my calculator just to double check this. So let's see. 6, 1 over 49. Oh, yeah, that should be a 1. Okay. Okay, I'm going to pause there and just sort of look to see if this is correct. So I got x plus 1 squared over 4 minus 1 times x plus 6 over 49 equals 1. Okay, that looks good. So now, look, the question is not asking for a graph. The question is actually asking for um, the equations of the asymptotes. Okay, let's draw a sort of a rough sketch of what this looks like. So let's see, here we go. Okay, so we know that the center is -1, -6. Okay, and so you already know 1 point. Sorry, you already know 1 point on the asymptote because you know the asymptote goes through the center and goes through the top corners of the triangles. So look, we need to figure out what the slope is. So if we ignore the center, if we pretend that this hyperbola is centered at the origin, then really it's this. Okay? And when you solve for y, you're going to get 4 over 49 x squared. Remember the one you can ignore because you're dealing with big, big, big values for x. When sort of like we've talked briefly about the idea of the limit. When you have a really, really big value for x, what is the value for y approaching? Well, when you square root both sides, you're going to get plus or minus 2/7 x. So it looks like the slope, excuse me, it looks like the slope is 2/7. So if you know the slope of a line and you know a point on the line, you can write the equation of a line. We did that earlier in the year. That should be really easy. So the point of the line is -6 comma -1. So, and the slope is plus or minus 2/7. So we're going to plug into Mr. Morrissey's favorite equation of a line. That's the point slope form. Remember, you're only going to plug into these 3 points. So both of the values for x and y are negative. So, whoops. So this is going to be plus 1 equals, let's do the positive slope. So there's the first equation. Multiply everything by 7. Okay, this question, I want to get, it didn't say this, but I want to get the answers in standard form. So 3, -5. So 2x minus 7y equals -5. There's the first equation. And then the second equation, since you know the asymptotes are positive or negative, the second equation is going to be the same thing, but with a negative slope. So multiply by 7 again. Make sure you distribute that -2 2 times. So -19. So 2x plus 7y equals -19. We are done. Oh, sorry. So we are going to sign off right now.